Did I guess we'll start now. Did any of you attempt the questions in the problem set I had put up? Or do you want me to just go through them anyway? Is that how you would like to do this? Good. What he wants help with. So, hi Ashwini, I see you're unmuted.
I mean, I think it would help if you just go through the problem set. For me as well, I haven't.
I'm just gonna go through the problem set. So let me just, can you see my screen now? Sorry, I should. So I had put up 5 questions. The first 2 questions I think are rather extremely simple. All you need to do is have a geometric understanding of stacks and queues in your head, right? If no one has any trouble with that, because in the way I made the slides, so I tried to do what Subodh did last time, which is to have a camera and work this out on a piece of paper, but I don't have an extra webcam. I ordered it and they have not delivered it because Amazon's now on Essentials only. So I'll try to do that for a future question answer session. But right now we're going to have to make do with slides. In the first slide, I have basically the solution to the first 2 problems. So you start with an empty stack and you push the first 40 natural numbers into it in ascending order. Subsequently, you pop 28 elements from the stack. And what are the elements remaining in the stack now? So what you're in a stack, what you will do is in ascending order. So you push in first 1, 2, 3, 4, and so now you have a stack in which 1 is at the bottom and 40 is on top, and then you remove the 28 elements. So you get so you lose let's say the numbers from 40 to 12 because you're removing. It is last in, first out. So when you pop the first element, you lose 40. When you pop the second element, you lose 39, and you come back to this. So this is essentially what you get. And the answer to the second question is also the same because I put it in descending order. So even though it's a queue and it's the first 25, the thing to remember is that this is the top of the stack. A stack has only a top. The bottom is never accessible. And in case of the queue, this is the front of the queue, and this is the this is the front of the queue, and this is the back of the queue. Because you're putting it in descending order, you first put in 25, then you put in 24, etc. Then you dequeue whatever is on the opposite side, so you end up with the same numbers. So I put it in as a very a warm-up exercise, and I hope it's trivial for everybody. The second question I have is, I think, a little bit more interesting. So the question is this: a guy called Raj, he thinks he's playing some game that involves dice with his friend, and he thinks his friend may be cheating. So he comes up with a strategy. In the next match, he's going to keep note of the results of the first 20 tosses. And if he sees that more than 15 of them are 5 or above, because he believes the dice has been biased in such a way it'll always give larger numbers, he's going to confront his friend about it. So now the first part of this question is, if the dice is actually fair, what is the probability alpha that Raj will, nevertheless confront his friend saying, this is a biased die, and as a result, he'll probably lose his friend. To understand that, so let's understand the question once again. Here I've written the question, all 3 A, B, and C parts of the question down here. Let us define X as the random variable representing the outcome of an unbiased dice. If you get an instance of a 5 or above, that is probability of you getting x greater than or equal to 5. That is the only two outcomes in the case of a dice that are 5 or above are 5 and 6. You have a total of 6 outcomes, out of which 5 and 6. So that's 2 out of 6. In the first case where the dice is actually fair, then you can write down this probability as 1 by 3. Now, to do the rest of the problem, you need to understand what a binomial distribution is. It's actually quite simple. There is some math, but don't get scared by it. I can explain it to you. So a binomial distribution usually has 2 parameters. One is usually called n. It is the number of trials. In this case, it is 20 because Raj has decided that in the first 20 tosses, that's how he's going to decide it. Then there is the probability of success, which we saw is because it's 5 or 6, which is 2 by 6, so it's 1 by 3. If you repeat an experiment which has a given probability of success many number of times, the binomial distribution is the one that describes how many successes you get, right? So the conditions for the binomial distribution to be the one that describes your situation is that each of your repetitions should be independent. So once you throw a die, the outcome of that process does not affect your next time. The next time you're throwing a die. So consequently, that situation is satisfied. The other thing is that you should be able to divide all your outcomes into basically success or failure, so that you have a probability of success, which is p, and a probability of failure, which is 1 minus p. So 1 minus p here is 2 by 3. What I've basically 1 minus p is 2 by 3. What I've basically classified here is that the outcomes 5 and 6 are to be considered success, because that will get the dice on the radar of Raj, whereas the outcomes 1, 2, 3, and 4 are not to be considered successful, because they're okay. Raj will let that fly. So then, if these are the parameters that define your experiment, K actually corresponds to the number of successes within that let's say number of experiments. So what Raj has decided is that if K is greater than 15, he's going to confront his friend. And so the probability that K is any value is now given by this distribution. Just to take you through this stands for the factorial. So n here, so this is 20 factorial divided by K. If you're looking at the situation that Raj gets 16 successes, that would be 16 factorial. And minus, yes?
Maybe explain what the factorial is.
Okay, yeah. If you're not, factorial, if I say 3 factorial, it is 3 into 2 into 1. So that is 6. If I say 4 factorial, that's 4 times 3 times 2 times 1. So that is 12 times 2, 24. So yeah, that's 24. If I say 5 factorial, that's 5 times 4 factorial. So which in this case 120. Is that? I hope that's clear to everybody. So a factorial is basically if I give you a number, an integer, and I tell you I put an exclamation mark after it. So that is factorial. Then you multiply that number by a number obtained by subtracting 1 from that number, and you keep that process going until you hit 1, right? So it's a very fast growing function. Like 100 factorial is an extremely large number. You can estimate it, but it's a very fast growing function, but it's conceptually very simple. All you do is you take the number, you multiply it by the number minus 1, and you keep doing that until you reach 1. Okay. So here, the number of trials in this case is 20. So n is 20, p is 1 by 3, and k is you need to think of the situations where k is 16, k is 17, k is 18, k is 19, or k is 20, because those are the situations in which Raj will confront his friend. So you can actually evaluate this with a calculator, since now I told you what factorial is. Most calculators, especially the scientific ones, have a factorial computation on it. But later on, when I pull up Collaboratory, I will show this to you, how to evaluate this sequence from using code.
I should also just point out that I actually promised Modish that this Q&A session that I didn't get around to presenting it. We'd go through a little bit of combinatorics as well, maybe some background material. So what I'll do is so all of these notations, all of these factorial, these combinatorial factors which actually enter probability theory. I'll put up a little explainer, maybe a little note or some links to explain where these numbers come from themselves and some examples of how they end up. So if you're not following it right now, just take what Ramiz is saying, as a given, and then I will add some material to explain this a little bit better over the coming week.
Yeah. So maybe I should prepare an introduction. No. Okay, yeah. I mean, I can explain to you if you have specific questions about these combinatorial factor. This is really it counts the different ways you can, order something. For example, if I say you get you get 16 successes, then you have 4 failures, but they can be arranged. You can have all successes as the first 16 and all failures as the subsequent 4, or you can have 1 success, 1 failure, 1 success, 1 failure, and then you run out of the 4 failures in like the first 8 trials, and then you have all the successes in the remaining. So
excuse me, sir.
Yes.
Sir, actually, I know about the how to calculate all these permutation and combination, but I don't know when to use permutation, when to use combination. For instance, in this case, in this question, I could not even imagine that it will take the question can be solved through this permutation and combination. So that's my problem.
Oh, okay. Right. So if you have, right. Here is the sequence of logical steps I used to argue that what you need is the binomial distribution. This is simply because he is repeating the same. Like once you throw a dice, and the second time you throw a dice, the outcome of the second time is not influenced by the first time, right? And in each attempt, it's 5 or above. It's 5 or 6. So it is the probability of what you consider a success is exactly the same. And those are the only 2 criteria you need. Any experiment that satisfy these 2 criteria will be binomially distributed. For example, the specific case that Subodh explained to you of tossing a coin is a limiting case of the binomial distribution, except your probability is 1 by 2 instead of 1 by 3, because a coin is always half and half, right? So that is the way to go. The permutation and combination here actually, once you decide that binomial distribution is what you want, I'll be honest with you, I do not remember this expression off the top of my head. What I do is I type out in Google binomial distribution, then I look at things, I write it down. And yes, this first term is actually the number of ways in which it is the permutation of it is NPK of N. It is the permutation of
I guess it is combination NCK. Am I wrong?
No, it is not the.
No, that's right. He's right. He's right. That is right. So this factor is exactly N choose K. That is correct, Modish.
Yeah, it is NCK, not NPK. Yes. So the thing to remember.
Go ahead, bro. I was just going to say when I add so precisely to answer your question, Modish, when to use one combinatorial factor versus another, I think I will try to come up with a short little, because it'll be useful for future as well. I'll come up with a short little note explaining all of these things with examples, right? So the way to really think about all of these things, it usually helps to just so in this case, right? So imagine what Ramiz is describing is, imagine you have 20 boxes, right? And either they're filled or they're not filled with some number of balls. And if you think of it in that way, if you usually break down all these problems into something different than what you're looking at, it makes it a little bit more clear. But of course, it just takes a bit of practice in terms of thinking of these things. So what I'll do is I'll come up with a note that'll explain some of these combinatorial factors, where they come from, and some examples to hopefully make it clear so you know when to use one versus the other. And I think what will be very useful, in fact, would be to maybe go through this other uniform, this very universal distribution called the Poisson distribution. I think we discussed it in one of our lectures. But the Poisson
distribution is also a limiting case of the binomial distribution where n essentially goes to infinity.
That's right.
And if you have a very large number of trials, you can think of, I mean, you can do it either using the binomial distribution or the Poisson distribution, but you'll find that using the Poisson distribution is much easier, as in the equations simplify, and the differences will get smaller and smaller the larger your n is. So, so since Subodh said he'll make I won't, but I'll just say that one of the most intuitive ways permutations are different from combinations for me is like a permutation counts, different orders, etc. separately, whereas a combination is just the number of, for example, we have two numbers, 1 and 2. You can permute it two ways. You have 1, 2 and 2, 1, but there is only one combination, that is 1, 2. And as in 1, 2 and 2, 1 are the same. You don't care about the order. So that is the main difference between permutations and combinations for me. But yes, this object is the probability that Raj will call out his friend saying this is a biased dice is given by the probability that he'll count 16 cases of 5 or above, 17 cases of 5 or above, 18 cases of. But you can also think of this in other ways. There are other ways to evaluate this. There is something called the cumulative distribution function, which is the sum of everything up to a point, right? And so yeah, I'll just show this to you when we redo this question with sampling, which is what I put as the 5th question. So for part B of this question, if the dice have actually been tampered with to land a 6 30% of the time, but all other outcomes are equally likely. Now, I kind of thought of how to do that. I don't think it's very easy to tamper a dice with in such a way that you can increase the probability of just one. So this is a purely thought experiment. As in, if you increase the probability of one outcome by like weighting the dice or so, there will always be a reduction in another probability. But if you could do this, what is the probability beta that he will not identify it as a biased dice, right? And so the only change you need to understand from this is that for part B, the probability of x greater than 5 is actually 44%. And how do you know that? Let us say 30% is the probability for 6. So you subtract that, and then what you have remaining is 70%. That is uniform, equally distributed among the other 5. So 70% divided by 5 is 14%. And so probability of 5 or 6 is now 30 plus 14%, that is 44%, right? So your P is 0.44, and then it is essentially, the same, but you are now summing every case from 0 to 15. I will help you. I'll give you a trick to, or at least to actually evaluate it by hand. It is equally cumbersome, but I'll tell you of a thing when we redo the same problem using sampling from using a notebook. So let us actually move on to the next question, and then we can revisit the same problem in problem 5, which is to verify answers of question 3, use sampling. But let us now open this in. You can still see what I'm looking at, right? So here I have given a data set, and the problems are defined as open this data set in a Jupyter notebook, open the array, what is the dimensionality of the array, how many rows and columns it have, visualize the distribution of amounts by making a histogram, 1 for all transactions, 2 separate histogram for those marked as fraud and not, 3 what is the number of bins you would. So yeah, these are the questions. What I'm going to do is I'll just straight away open this in Kaggle, right? So so if you go to that web page,
So Ramiz, if we click the link on the problem set, it would take us to this page.
it should take you to, yeah, let me put it that way itself so that,
Sir, yes, sir, it is opening now.
Sure. So which page are you seeing? Could you?
Sir, it is a synthetic financial database for fraud detection.
Yeah. So you see this page, right?
Yes, sir.
You see the same page. I am now logged into Kaggle. I would recommend that if you log into Kaggle, you will see. You can open a notebook even also without logging in, but you don't have much resources, so you can't open a data set this big. So now let's click on new notebook, and what you get is a notebook that Kaggle will basically prepare for you with some lines in it. It is automatically done by the system, so you will notice that it is importing something called NumPy, which is numerical Python for linear algebra, and it is importing something called Pandas, which is it is by far the most popular tool for data analysis with Python. So I think you should, you should start by working with Python. So what this is doing is it is going in this location, and it is looking at the list of files and is just printing it out. And see, this data set is there. So what we are going to do is now we will open this. Let's say. Yeah, it's not load. So you do read _ CSV, and you give it this file location. So you can copy, paste this. Of course. So I imported pandas as PD, so which means Python doesn't see it as pandas, it sees it as PD, which means I should do this, and it is now running it. So meanwhile, what we will do is we will print out this DS just to see what is there in it. Right. So now it will give you all the data inside this file as an array. It is currently running. You can see the status of the run. So it has already run it. And here are these are the columns you have, and these are the number of rows. So now let's see. I'll print this out. You see the list of columns. So if you want to see the list, the number of rows, number of columns, you just do len for length. It will show you 11. If you want to see how many entries are there, you can just check the length of one of the arrays in it. So you can check amount. And there are 6,362,620 elements within it. Right? So to open it, these are the things you need, and let's just keep let's keep DS printed so that we know what all are there in it at all times. Okay? So this will always be visible, and you can now print this out. Great. What was the first step in the assignment? The first question was open this in a Jupyter notebook as an array. What is the dimensionality of the array? How many rows does it have, and how many columns? We already checked that, so it has 6,362,000. Yeah, these many rows, and then it has 11 columns. Right? Visualize the distribution of amounts by making a histogram. One for all transactions. So you will notice that I have not actually put in any package for plotting. So I have to redo this first line. I have to change this. I will say import matplotlib.pyplot as plt. So this is a package for plotting. And because I'm inside a notebook, I think I need. These are all really trial and error. Okay, sometimes in some of these online environments where it is already deployed for you, you don't need these pre-processed statements like these. I'm not 100% sure about it. You have to try and figure it out. But I think here you do. So I'm just going to run it again, and so now we have matplotlib. All you need to do is we have imported it as PLT to make it a histogram, which is visualize the distribution of amounts by making a histogram. You say DS. The name of the column is amount. So now I can draw this. Oh, why is it saying that? Thought I ran this. Okay, so I must have forgotten to run it after I type it out. I have imported PLT, so PLT is available now, and with this I can make it a histogram. And as you see, this is not really useful because it seems to have only one visible bin. So we need to actually increase the number of bins, for which I will say, hey, make 200 bins at least. Let's try that. What do you get? Now you get the output from, and this is still not, so the reason is this. If you look at your y-axis range, it is a very large range, and it goes from 0 to a very large number. So when you have such problems, what you should do is you should make a log scale figure. Okay, so I'll try this now. Y scale log. So now you see a histogram, right? So this is now allowing you to visualize all the transactions. What this means is that the vast majority of transactions in this database have values very small. So you can further increase the number of bins to, let's say, 2000 if you want, and take a look at it. It will take a longer time because there is more processing to be done. But you see, the bins closest to 0 are the most populated. So the question specifically says, separate histograms for those marked as fraud and not. So let's do that now. I can simply cut this array based on a row. So what I'm going to do is to identify if a transaction is fraud or not. There is a column within the data set called is fraud. If it is 1, it is fraud. If it is not 1, it is not fraud. That is how this data set has been provided to us. So what I'm going to do is this is me telling the array that it should pick out only elements in which the column corresponding to is fraud is 1. Is that clear to everybody, or do you want me to do an explicit example of how doing this picks things out? In my experience, when I learn things like this, I usually just take an example where these things are usually there. So for example, if you Google pandas select from array, you will see many examples, and then you take the syntax and you change things in it to learn. So
it would help me if you went through an example.
Okay.
It would help me if you went through an example.
Sure. So ds of is fraud. This gives you this column of the array. Okay. So now you can see that there is just a reference number which gives you the indices and just that column. Now, if I say equals 1, then it evaluates this condition, that is this column equal to 1 for each of the rows. So as you can see, for the first 2 rows, it is actually 0, it returns false. For the third row, it returns true because the third row is 1, right? Now this actually is an array itself, which you can use to refer to DS. Okay, so if you do this now, what you get is a subset of the array in which everything is fraud. So now you will see that the number of elements is only 8,213, and there are still 11 columns, whereas earlier you had more than 6 million rows and columns, right? So by applying this criterion to the array, you find only the entries where everything is fraud. Is that clearer now to everybody?
Yes, sir. Sir, do we need to remember these commands?
Well, if you're working very fast, you do. If you need to work very fast, you do, and I think you will automatically. But in my experience, I don't know how good advice this is, but I usually don't remember almost anything in programming. I usually type things out, I find an example, and I change it, which is why. If you wanted to just go like this again, let's just so you have this. This shows you the entire array, and you see the list of columns in it. So there is a column called is fraud. You can get that by typing out right? And this gives you now just the column. You can apply to it the criterion 1 to get an array that is basically the value of this statement. You know, in programming, maybe I should explain this from scratch when I'm teaching programming, but many of you are probably familiar with this. Each statement that you write down, especially one with an equal to in, has either a true or a false value. So when you apply this to an array, what you get is now an array of trues and falses, right? And so now this array can be used as an index for the original array. To do that, what you do is you just put this in a square bracket of the array, and if you run it, you get only the entries in which it is marked as fraud, right? So I applied that criteria here, and then I'm pulling its amount column, and if I do a histogram for this, I see, so now I can reduce the binning if you want, and you see more bins, right? It's each bin contains more elements. So the question of visualize the distribution of amounts by making a histogram for all transactions, separate histogram for those marked as fraud and not, and what is the maximum number of bins you would choose for these histograms? Does anyone want to tell me what is the maximum number of bins you would choose for these histograms? Or do you have any idea, Modish, or anyone else? What would help you judge that, make a judgment on that decision, just to visualize the data?
Sir, in what we have studied is that generally we don't have that big data. So we have a maximum at the max we have data in thousands. So we will divide that in class intervals like 100, 10 or 50 maybe. So 50 size of bins. So that kind of can be done by dividing, the kind of spread we have.
Yeah.
But in this big data, sir, I don't know.
Actually, no, what you have said is basically the rule of thumb. You can't have more bins than data points, because then it is no longer a useful histogram, right?
Yes,
a histogram is supposed to count how many things are in an interval and give you that. If you have as many bins as data points, it no longer becomes essentially useful. So I can illustrate that here by, for example, let's say there's 8,213 rows. So let's now put something like 16,000 bins. What you're going to find is you'll have some bins in which there are multiple ones, and then you'll have a lot of bins which have just one, which is probably not useful to visualize things that way. Also, because I gave a large number of bins, it's computationally intensive, so it's taking some time to do it. Sorry, this, yeah. So yeah, look at this, almost just the first few bins are populated, and then beyond this, everything has just one or two elements in it. So yeah, a good rule of thumb for the number of bins is definitely not more than the number of data points, but it really depends on how things are distributed also. So yeah, I was only asking a very how do you judge how to visualize things, that sort of question. So this completes our part C of the question. The part D is very simple. Is it okay to assume this is Gaussian distributed? How would you check? Is it okay to assume this is Gaussian distributed? So you have seen the normal or Gaussian distribution that Subodh has shown you. You know its shape. You can tell from the shapes here. Is this Gaussian distributed? Can someone tell
Sir,
me?
no, sir, it's not. It's not normally distributed. Sir,
Exactly, because it's not a symmetric shape, right?
yeah. Sir, data is skewed, so it should be, I guess, uh, 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 it should be, maybe it is a, uh, what we can call.
It it in economics and social sciences, these sort of data are usually called Pareto, etc. Sometimes it's a power law. The more you
Data charts. Yeah.
so those distributions anyway we will learn in future classes, but I just wanted to just tell you that looking at the shape of a histogram is roughly how you decide how the data are distributed, what kind of a probability distribution function you should use for it. But this is definitely not Gaussian distributed, so you shouldn't be doing any tests on this data on this variable assuming that it is Gaussian distributed. So the
So I'm using.
Yes.
I just wanted to drop in something entertaining. So Ramiz just mentioned that this distribution has the form of this thing called the Pareto distribution, and Pareto himself observed that there are many things in life like this, and one way of understanding it can be expressed in words is that in many situations, let's say the wealth in a country, he says something like 80% of the wealth is in the hands of 20% of the people. Or you could say something like, in a given company, maybe 90% of the work is done by 10% of the people.
Yes, sir. Exactly.
This is a colloquial way this is a sort of an idiomatic way of expressing what this distribution is actually showing. So the Pareto distribution is showing precisely this.
Sure.
Yes, sir.
The last part of this question is make a scatter plot between the amounts of the transactions and the initial balances before the transactions. So to get the amounts, all you need to do is put this, amount. And similarly, what is the name of the initial balance of the account before that array is given by this, right? Sorry, I appear to have old balance. So if you now run this, you get the amount of initial balances. And great. So the way to make a scatter plot is now plt.scatter. The first array is what you want plotted along the x-axis, and the second array is what you want plotted along your y-axis. Give me a second, let me switch on the light in my office because I can't see much. Yes. So now I can do it's taking a while again because it's a large data set. Perhaps I should have. Yeah. So this is what the scatter plot tells you. This is not informative at all. I don't understand why there is now a branch. So we'll have to investigate this a little better, right? But one of the things it tells you is that.
So Ramiz, what's happening there is this happens often is the resolution of your dots is very big, and what's happening is that there's a lot of zero entries. So the scatter is what you see is that a lot of the zero entries are. So there's noise there, but the noise is looking like there's a fork.
Sure.
Do you see?
So yeah.
If the dots were smaller, it would look like a noise. It is. You see what I mean? It would just.
So one of the ways you can get around this would be to just cut away the noise, right? So what you're plotting along the x-axis is the old balance, and let's just look at the cases. Let's cut the data.
So Ramiz, would one way to get rid of the noise, do you think, be maybe to just put a threshold, say below a certain score, we just throw away the data? Would that get rid of this noise, or is that not useful here?
Yeah, that's what I'm about to just do. I'll just do greater than 100, right? So that, but this. So now what I'm doing is I'm selecting only the data points, only the columns in which before the transaction the amount was at least greater than 100. And so if you now try to plot it, let's see what happens. Oh, wait, I'm still plotting DS, not DSC, right? That still doesn't help. So we have an idea. Changing both the scales to log. So this will let you choose smaller points, etc. For example, if you choose 0.01, you get an even finer. So what you're basically seeing here is now that there are a large number of cases where you have your original balance was, let's say, what you have along your x-axis is your original balance, and what you have along your y-axis is your transaction amount. And what you see in these lines are the points where your transaction amount was of the order of a very large number, while your original balance is small. So they must have been incoming transactions. So yes, there are also transfer types. For example, let's cut on that also, just to get an idea of. Of course, I think I need 2 equal to's. So now we are looking at only outgoing transactions. And what do you see? You see that the amount which is along the y-axis is always, is that? No, the amount is now still, there are points where the amount is larger than the old original balance. So maybe I'm looking at a wrong, let's look at the name of the columns. This is the balance in the destination before and after.
So Ramiz, I think we're running out of time.
Yeah, I'm sorry. So, but well, the main point was to illustrate how to make a scatter plot, and this from a programming point of view, this shows you how that works. But I'm not 100% sure this data set makes sense, or that how we are plotting this is useful, or it is teaching us necessary points about it. But we can revisit this in the next lecture.
Nevertheless, I think. But nevertheless, I think this is an important lesson as well, right? Which is that data is noisy, it needs to be cleaned, and we're seeing an illustration of it here, right? Is that it's not always easy to extract from it useful information, and that we have to think about it on a case-by-case basis as well.
Yeah, and for example, there would be common sense rules like an account cannot go into negative because I don't think banks will let you transfer that much out, which is why I was thinking that if the original balance is smaller than the transaction out, once you have applied it to be cash out, it shouldn't be there. So I'm surprised these data points are here, but maybe I made a mistake somewhere. But anyway, I think this concludes most of the point. It gives you hands-on how to play with this data set. Especially Modish, you said you had problems with visualizing this, right? And do these things help you?
Yes, sir. Yes, sir. It was very much useful.
Okay.
But sir, my problem is, sir, I don't remember these codes, and I'm struggling in running the data. I mean, I get error quite often.
Sure. My go-to strategy in all of these things is to type it out into Google, copy paste code, and modify it until it works. It's a trial and error strategy usually, and that's how I do things. So
yeah, Modish, I think it's the same for me, right? I think you see, coding is the kind of thing where you don't always remember all the instructions, but what you should be able to do is read somebody else's or read some code and then understand what it's trying to do and then be able to modify it for your purposes. If you can get to that level, you are essentially functional enough to address most of the problems you'll ever come across. I think this is how most people, it's only extremely professional coders that can code from scratch. Would you agree with that statement, Ramiz?
Yeah, I mean, yes. So also, yeah, I completely agree with that statement. Extremely professional coders can probably code from scratch, or if you have like 2 years of experience coding only on Python, you can do that from scratch. But for example, I went from showing you what the data set looks like to how to select one column, how to select just the entries that have a value for that column, etc. And yeah, building it up step by step is usually the way. Like, don't try to do a big thing at once. When you don't understand the syntax, etc., just try like picking an element in an array, and then keep building on that. That's how I would say. But yeah, I'm sorry we're out of time. If you want, I can do on Monday after the main lecture. I can do this in more detail, or in our next question answer session we can make it longer, because on Friday evenings I have time. So,
sir, can we, if it is possible, only then I am saying, sir, can we have, we can have some kind of experience. So you will provide, you will dictate us, and we will do it here in our laptop for
sure.
for for 10 or 20 minutes, so that we get acquainted. अभी तो शुरू से यही नहीं पता कि कौन सा पैकेज कौन सी, ये भी अभी पता नहीं है ना
So,
कि कौन
the
कमांड
problem
देनी
that
है.
I gave you, there is a link. If you click on that, then you reach, you reach a page like this,
Okay.
and there you can click new notebook, and then you can you reach here. You have to. So I think what I can do is I can also save this notebook now, and I can put it on the Nalanda, the Google Classroom, and so you can open it. I shall do that.
But I think, but I think a class session where we work through an example together would be useful, even for me, because
okay.
I would find it very useful.
Next question answer session, which will be next Friday. Let's make it 2 hours, right? Is that okay for everybody?
Yes, sir.
Sure. Because then I can work it out in detail live, and you can and those of you who can connect with your laptop, and you can also try the same thing. And what I will do is I will also, before that, share this notebook on the Nalanda page. So it will be an IPYNB file. You can download it, you can put it into this system, and you can run that notebook yourself. So that would be a way to go about it. Yeah, thanks. So out of the 5 questions, we have kind of worked out 4. The 5th one, we shall do it next time because we ran out of time. Does anyone have any questions you want to ask?
So I just wanted to add that between this introductory, really, because what Ramiz and I are doing right now is just introducing you to some basic things. Between this module and the next module, which will be more advanced, we will set up a little coding academy. So I think it's very nice that Ramiz has actually started to go through a few examples. So you're starting to see that it looks like a lot of syntax you don't understand. It's the same thing for us, okay? But if we just sort of go through, for those of you who already know how to code, then fantastic. This is not going to be, you don't need this. But for those who don't, it's essentially just being able to understand what code is doing and then being able to modify it for your purposes, and that you can do fairly quickly. And we will set up a little, maybe 1 or 2 month coding academy in between, such that when we do the second module, it will be more like what Ramiz is doing now, where every class we work through, some real examples, and we'll introduce other software packages commonly used in data science, such as RStats and so on and so forth, because these will be the common things that you will come across if you ever have to interface with jobs or in your academic discipline or industry.
Yeah, that'll definitely do. It's also, I'm sorry, this question answer session was a bit too chaotic. I believe I'm a little unprepared. I'm sorry. Next one will
It was very good.
Next one will be a lot better, I promise.
I think this is excellent because you actually showed what the life of a real data scientist is like. Because if you actually go into a real data science job, it's like this, okay? You think you have a solution, you apply the solution, it doesn't work, right? So then you have to see why it doesn't work. And we're going through this process now. So I think this is actually very illustrative.
Yeah.
So honestly, I enjoyed it.
Sure. Yeah. For example, right now, I have no idea why once I applied that cut, there are data points here, which seems to suggest that there are transactions in which there is more amount going out than there is balance in the account. what I'm going to do is I will investigate this. Maybe it's even possible because these are simulated data sets that there is a mistake in the data set. But I'll let you know, right? I should have been a little bit more prepared. I thought the data visualization bits I will just do on the fly and it'll all look perfect. But obviously that's a foolish thing to think. Right. Thank you for connecting. Don't hesitate to email me if you have questions. I will share this notebook on the Nalanda Academy Google Classroom page, so that you can just put it here and you can run it yourself. And then all the syntax issues that Modish was complaining about, because you will have one example in it, hopefully he will not find the rest of it difficult. Thanks. Yeah, I think that's all for today.
Thank you, sir.
Thank you, sir.
Bye, everyone. See you on Monday.
Bye, sir. Thank you.